Every device connected to a network gets a unique IP address. IPv4 addresses are 32-bit numbers usually written as 4 decimal numbers, called octets, separated by periods. Depending on the network size and requirements, these addresses are divided into different classes. Class A addresses range from 1 to 126 in the first octet. With an 8-bit network portion and a 24-bit host portion, they support a few huge networks with more than 16 million of hosts each. Big companies and major networks often use Class A addressing. Next is Class B, covering addresses where the first octet runs from 128 to 191. They use 16 bits for the network and 16 bits for hosts, offering a middle ground ideal for medium to large networks like universities or large businesses, and support 65,534 of hosts. Class C addresses range from 192 to 223 in the first octet. They dedicate 24 bits to the network and only 8 bits to the hosts, which limits each network to 254 devices. This makes them perfect for small networks, like those in small businesses or home settings. Then we have Class D, from 224 to 239, reserved exclusively for multicasting, sending data to multiple devices at once. Class E, from 240 to 254, is experimental and not typically used for everyday networking. Beyond public IP ranges, there are reserved blocks to maintain network security and stability. For instance, private IP addresses ranges aren't routed on the Internet, allowing secure internal networking. In Class A with 10 in the first octet. In Class B from 172.16 to 172.31 in the first and second octets. In Class C 192.168 in the first and second octet. Additionally, in Class A loopback addresses with range 127 in the first octet let a device communicate with itself for testing. In Class B link local addresses with range 169.254 in the first and second octets enable local communications when standard IP assignment fails. These exclusions prevent overlaps and potential security loopholes in global